When Emerita Professor Mary Garson came to Australia, the first thing she set out to do was learn how to snorkel and scuba dive.
I needed to go underwater and collect the specimens myself. And this was a bit of a voyage of discovery for me, a voyage of learning, because I could not swim very confidently.
She was researching marine sponges and the defences they use in their natural environment. Professor Garson was fascinated by their chemistry.
Looking up the chemistry of marine sponges is a little bit like trying to decipher a molecular jigsaw puzzle. We use a technique called nuclear magnetic resonance spectroscopy to investigate the different types of atoms, the hydrogens and the carbons in the molecule, and also to understand how those atoms are connected to each other.
Life underwater is a competition for space and food. Marine sponges use a range of bioactive chemicals to defend themselves against predators such as fish and crabs. Professor Garson's pioneering work has been on investigating the function of these chemicals and defining the unusual pathways through which they're manufactured.
And I was able to establish that, amazingly, the marine sponge is taking a precursor, cyanide, which is a poison, and converting it productively into a bioactive molecule, diisocyanoidosine, which it can use in its chemical defense.
Sponge metabolites like diisocyanoidosine often provide protection in other ways, such as by inhibiting the growth of pathogens and other marine biota. Some of these molecules also have pharmacological properties that could be effective against cancers and infectious diseases. Professor Garson says she's had an enriching career not only because of the scientific discoveries. One of her personal highlights was having a marine flatworm, Maritagrella merrigarsoni, named after her.
When I was a third-year student back at university in England, if you had said to me that I would end up going scuba diving on the Great Barrier Reef, undertaking science on marine bioactive chemicals, and ending up with a little marine animal named after me, I would have said, "Oh, you must be joking."
Professor Garson has shifted her focus to leading and inspiring the next generation of scientists. Since 2019, she and her colleagues at the International Union of Pure and Applied Chemistry, or IUPAC, have run an initiative called the Global Women's Breakfast.
What happens at one of these breakfast events is that there is informal conversation about breaking barriers in science, catalysing diversity, and the conversation includes men as well as women.
Professor Garson is now Vice President of IUPAC and in 2026 will become its Global President, the third woman and second Australian ever in its 104-year history to hold this title. She sees this as an opportunity to help put Australia firmly at the centre of the global science community, a mission she also hopes to propel forward as a Fellow of the Australian Academy of Science.